Hello friends, welcome back to my channel. In today's episode, we are diving into one of the most popular pattern in array problem, that is the sliding window technique. Here the problem is find the maximum sum of a subarray of size k, and the problem statement is you are given an array of integers and a number k. Your task is to find the maximum sum of any contiguous subarray of size k. Here, let's look into the sample input and output. Input has given array of 2 1 5 1 3 2, and the size has given k equal to 3, and the output is 9. In this below explanation as given, like subarray of 513 has the maximum sum of 9. So in this array, subarray of 513 is the maximum. Okay, now we'll go for the brute force idea, and the brute force idea is we have to loop through all the possible subarray of size k. Then for the each subarray, we have to calculate the sum manually using an inner loop, and we have to keep track of the maximum sum found so far, and it will return the maximum after checking all the possible windows. And in this brute force idea, our time capacity will be big O of n into k, because we are going each of the element, and also we are taking the size k. Okay, so it will be big O of n into k. That's how the brute force approach works. It is simple but not very efficient when the array becomes large. Okay, but today's session I will discuss on optimized approach using the powerful sliding window technique. All right, let's now go through the code line by line and understand how it works. We'll be using Python here, but the logic remains same in any language. Okay, here we defined our function called maxSumSubarray that takes two input, an array and a number k, which is the size of the subarray we are looking for. Okay, first we calculate the length of the array and store it in n. Then we check if the array length is less than k. If the array length is less than k, if yes, that means we can't form any subarray of size k. So we just return none here. Now here is the sliding window magic. Okay, here is the sliding window magic. We first calculate the sum of the first k element of the array. This is our initial window. Okay, think of this as the first fixed size subarray, the starting point of our journey. Here we store that initial sum in a variable that is called maxSum. Okay, this will help us to keep track of the maximum sum we counter while sliding the window. And after that, like in this step, we loop through the rest of the array starting from index k up to end. Okay, step index k to up to end. This loop is where like we keep sliding the window one step at a time. Hope you understand up to this. Okay, now inside this loop, we update our window sum. Okay, we update our window sum by removing first element of the previous window and adding the new element at the end of the current window. Okay, let's say the previous window was from index 0 to 3, and now we remove the index 0 and add the index 4. Okay, this way we don't need to recompute the sum from a scratch each time, and it saves a lot of time. Okay, uh, here after updating the window sum, we check if this new sum is greater than our current sum. If yes, we update it. Okay, now at end, finally after the loop ends, we return the max sum, which is the maximum sum of any subarray of size k. Okay. Now let's talk about the time and space complexity of the solution here. Okay. Here with the sliding window approach, we are traversing the array only one using single loop. Okay. At each step, we removing one element and adding one element to the window sum. Okay. So entire algorithm is big O of n. Okay. And the like time complexity here is big O of 1 because it taking constant space here. Okay, hope you understand that time and space complexity. Okay. Now for this code, let's dry run this code with sample input to understand how the sliding window works. Okay, so this is the given example here. Okay, so and the examples are given like 2 1 5 1 3 2, and the subarray size has given k equal to 3 here. Okay, so very first we calculate the sum of the first k element. Okay, so our first window is we can say 215, and also I have indicated with color. Hope you guys are see these colors. Okay, I've indicated each of the subarray here. Okay, so first current window element you can say 215. It is 215. The index 0 from 2, as the range has given k is equal to 3. So index is 0 to 2. Okay, and the you can say here windows sum calculation has given like 2 1 5, 2 plus 1 plus 5, and the windows sum become 8 here. Until this, the maximum sum is also 8. And the very first step will slide the window by 1. Okay, I. Okay, 1. So the new slide, I mean subarray become 1 5 and 1. This you can see the yellow color. Okay, 151. Also I have written here 151. So now the windows sum calculation will be like we have removed the index, okay, 0, and we have added the index 3. So calculation is like maximum sum minus index 0, that is 2, and have added the index 3, that is 1. So we have minus the index 2, minus the index 0, and added the index 3. So now sum becomes 7. Okay, and till now max sum is also, I mean, it's 8 only. Okay, and the second step is like we have here we have slide the window again. Okay, you slide the window again by 1, you can say by 1 index. So the new index, I mean the new subarray will be 513. The black color you can see here 513. So here what we have done is like we have removed the index 1 and added the index 4. Okay, you can see here clearly. So the calculation will be such as like I mean say window sum minus window sum minus what, it will be index minus index 1 this time, and we are adding index 4, that is 3. So we are just you can say we are doing minus with 1 and adding with 3, so the sum become 9 here. Okay, the window sum become 9, and till now we can say 9 is the max sum in this array. Okay, so it updated with the 9. Now the very you can say the last step you can say. Now in this subarray we have again we slide with 1 index. So this time what we have done, we have just uh, I mean you can say remove the index 2, right? Remove the index 2 and we have added the index 5 here. Hope you can see in this like kind of blue color. Okay, so and the current window element become 132. This is 132, and the calculation we can write such as like window sum minus index 2. Index 2 is 5 plus index 5, that is 2, and total equal to 6. And the till this time again our max sum is still 9. So the sum of the subarray of size 3 is 9. And I'm hope like you all are understood this dry run and for this example. Still you have any doubts, so please write your doubt in our comment section. I will answer your each and every doubt. So let's go now to lead code and check the our program whether it is running or not, or we are getting any expected output or not. So let's go to lead code. Here in the lead code, I have already written the code for the same input, and now we'll check for the output. Yes, we got the expected output with the range, or you can say k equal to 3 as 9. That's all for today. Now we go to recap and call to action section. Let's go. We have started with the brute force approach, which checked every subarray of size k. Then we optimize it using sliding window technique, and there it reduced the time complexity from big O of n into k to big O of n. We also did a step-by-step diagram to understand how the sliding window work in real time, and finally we have solved this problem into lead code also. Yes, at last, like if this video helped you, so please show some love, like this video and subscribe to my channel Make Easy Code for more easier DSA video. Thank you. See you in the next video.